Okay, this is the P4 paper from June 2022. It's question number 7, and as you can see by looking at it, it's going to be differentiation and differentiating parametric equations. So let's have a look. It says x is equal to sine t minus 3 cos squared t, y is equal to 3 sine t plus 2 cos t, t being between 0 and 5. Show that dy by dx is equal to 3 when t is equal to pi. So that's relatively straightforward, so we can make a start on that. So as we said, we've got x is equal to sine t minus 3 cos squared t, and so dx by dt, differential of sine is cos, and the second part, treat it like a squared function first, so multiply by the power, take 1 off the power, which is going to give me minus 6 cos t, but then times by the differential of cos, and the differential of cos is minus sine. So I'm going to put the sine t there, but I'm now going to change that sign to a plus. You really shouldn't have any problems doing that type of differentiation by the time we're at this stage of P4. Let's have a look at y. We've got y is equal to 3 sine t plus 2 cos t. So following exactly the same idea, we shouldn't have any problem differentiating this. Differential of sine is cos, so 3 cos t, and differential of cos is minus sine, so minus 2 sine t. And they want us to do dy by dx, which is dy by dt, no problem with that, but the dx by dt needs to be turned upside down. Dy by dx is dy by dt times dt by dx. If I actually flipped that upside down, but this is relatively standard, so what that's going to mean is I'm going to get dy by dt, 3 cos t minus 2 sine t, but if I'm timesing by dt by dx, I'm basically doing 1 over, which means I can just do divided by cos t plus 6 cos t sine t. So if you've done any practice of this sort of thing, that should not be a surprise to us at all when we're doing that. What do we need to do with it? It says at t equals pi over 3, find dy by dx. So, excuse me, at t equals pi over 3, dy by dx then is going to be equal to, okay, so it's 3 cos pi over 3 minus 2 sine pi over 3, excuse me, all divided by cos pi over 3 plus 6 cos pi over 3 sine pi over 3. I keep not starting that far enough to the right. I'm not going to bother, showing you how to do that. Just stick all that into the calculator. If it was a complicated thing, then we might go through it, but it actually all works out to be equal to 3. So part A done. What does part B say? So part B says point P lies on the curve where t equals pi. So that same point there. So we know dy by dx is equal to 3, and it asks us to find the equation of a tangent. So if I want to find the equation of a tangent, just remind ourselves, for the equation of a tangent, equation of any straight line, but the equation of a tangent, I'm going to do y minus y1 equals mx minus x1. So we know over here that m is equal to 3. We've got to find x1, y1. So that's nice and simple, because I know that for x1, t equals pi over 3, so just put that into the formula for x. So x is, we said it was sine t, so sine pi over 3, minus 3 cos squared t, so minus 3 cos squared pi over 3. That works out to be equal to minus 3. For y1, then, t is still going to be pi over 3, y is going to be equal to whatever the formula was for y, which was 3 sine t, so 3 sine pi over 3, plus 2 cos t. And let's work out what that works out to be, and that's minus 2 So I've now got my x1, y1 and m as being those three values. So we can just now stick those into the equation. So y minus y1 is y minus minus 2, that's y plus 2, is equal to m, which was 3, x minus x1, x minus minus 3 is x plus 3. Now the question said to tidy that up to be y equals mx plus 3, and that actually works out to be y equals 3x plus 7. It says there, look, put it in the format y equals mx plus c. Okay, given that the tangent of the curve cuts C at the point Q. Now, even though I don't know what this curve looks like, let's just do a quick sketch just to be able to say what's going on. I've just made this sketch up. What we're saying is we've got a tangent at the point P, and what's happening with this equation of a tangent is it's hitting the curve again over here. So there's P, it's hitting the curve again at a point Q. So if it's hitting the curve there, what I need to do is I need to solve when does this equation meet this equation, okay, solving the two of them simultaneously. Now, I didn't need to draw that in necessarily, it's more just confirming to you guys, but also confirming to myself, what am I actually going to do now for part C? So for part C, what we're saying then is for Q, for the point Q, I've got y equals 3x plus 7, and I want to find where this meets. We've got it as a parametric, but x equals sine t minus 3 cos squared t, and y equals 3 sine t plus 2 cos t. So if they were just normal equations, we could just put them equal to each other, but either way, I've got to solve this simultaneously. So the easiest thing to do is to just say, okay, well, I know x. If I put sine t minus 3 cos squared t in there, and I put y in there, then by putting those together, I'm solving the equation, and I'm pretty sure that's going to end up with what we're trying to target as our answer. So let's do that. So the y1, which is 3 sine t plus 2 cos t, just be careful you don't make any copying errors when you're doing this sort of work, is 3 lots of the x, which I've got there now, which is sine t minus 3 cos squared t plus 7. So the solution to that will be the solution to find point Q and point P, but we'll find point Q. So doing that now, we're trying to get it equal to something, so let's just multiply this all out. It should just drop out nicely. I get 3 sine t plus 2 cos t is equal to 3 sine t minus 9 cos squared t plus 7. And what I noticed as I was saying those was that the sine t's are going to cancel. I've got 3 sine t and 3 sine t, so when we're rearranging this, they're just going to disappear anyway. With the cos squareds and the cos, just get it as a quadratic equation. So I'm going to chuck everything over to the other side there, and if I do that, I'll end up with 9 cos squared t plus 2 cos t minus 7 equals 0, and that's what we were trying, I'm hoping that's what we were trying to do. Yeah, that's what we were trying to do there. So we've done that part, and then it says find the exact value of the y coordinate of Q. Okay, so if I solve that, I will actually find Q. Okay, so solving that. Now, I would normally probably put this into the quadratic formula. It's only because I've actually already done this before that I know that this one actually does factorise, but it's not one that I would necessarily straight away see as factorising. I'd certainly suggest if you're a strong factoriser that you have a go every single time at one of these quadratics to see if it does factorise first. But obviously you don't want to waste too much time in doing that, in terms of you can stick it into the formula quite quickly and get the answer as well. So here we're going to get 9 cos t minus 7 equals 0. So cos t equals 7 over 9, or we're going to get cos t plus 1 equals 0, cos t equals minus 1 there. Now, we only want one of these values. Which one do we want? Well, actually, if I was to go ahead and solve that one, I would get that t works out to be equal to pi, and that's the p-value. Okay, that's the other value. So we know when we're trying to do this that it's not that. So I'm going to get rid of the underlining. It's not that one that I'm going to be using. It's that one. I don't think you necessarily, if we were, well, maybe we should say this value leads to t equals pi, which is p. You do not need to write that down because they're only asking this for q. But if there was another style of question, we might need to say why we're getting rid of one of the values here. Okay, so cos t equals 7/9. What we're trying to do, we're trying to work out y. So if we're trying to work out y is equal to 3 sine t plus 2 cos t. Well, I've got cos t, that's okay, that's 7/9. But what about sine t? I haven't got sine t. It's a quick little thing to do. All we need to do is to say, oh, that's not very neat, is it? Is to say, okay, if I'm saying that t, cos t is 7/9, so cos t is 7/9 here, which is adjacent over hypotenuse, what I can do is I can work out what this missing side here is, okay? If I work out what that missing side is using Pythagoras, so let's just do that first. Let's call that O, I suppose, for opposite. We can say opposite is equal to 9 squared minus 7 squared square rooted. I'm not taking any time over this because I just want to get the value there. It's actually root 32. So if that's true, then here y is equal to 3 sine t. Well, sine t is going to be opposite over hypotenuse. So that's going to be root 32/9. And 2 cos t. Cos t we've already got is 2 7/9. Stick that into the calculator. I think it says, does it say to find the exact value? What does it say? Find the exact value for the y coordinate of q then. So stick that into your calculator. It works out to be 4√2/3 plus 14/9. And that's good enough to have as the exact value. Okay, nice question, that one. Hopefully that all makes sense to you.